I'm Dr.S.Sahaya Selvi, Assistant Professor and Head, Department of Computer Science, St. Joseph's College for Women, Tirupur. Like to present explanation on merge sort, which comes under design and analysis of algorithms. The merge sort is a sorting technique based on divide and conquer strategy. It divides the input array successively into two halves until single element is left out in the subarray, then merging the two subarrays again successively, working up to the top input array, at the end getting the whole input array in sorted order. This merge sort follows the recursive algorithm. The algorithm of this merge sort involves two main functions, merge sort and merge. The merge sort accepts three values as the parameters: array, the lowest key index of the array, and the high index of the array, which can also be put as left and right index, which divides the array into two. Whereas the merge function accepts four values as the parameters: array and the leftmost index and the rightmost index put as R, and the middle element, middle index as M, which is going to be the key process which is going to merge the two subarrays which are going to have the values array, which is low to middle value, and the middle value to high value, are going to be merged and resulting in sorted order. Fine. So the first step is going to be find the middle point to divide the array into two. So here the whole algorithm, say for example, if it is going to be called like merge sort, the array, left index, rightmost index, if the based on the condition right index has got the highest value than the lowest index. So here we will be calculating the middle value based on the formula left plus right divided by 2. And again, it is going to first we will be calling the merge sort for the first half, which is going to be the array, lower index, and the middle index. And the third step is calling the merge sort for the second half, which is going to be called merge sort array, middle plus 1 the index till the rightmost index. And the fourth step is we have to merge the above two halves, which results after executing the second and third steps. So we have to call merge array, left index, middle value, and right index. So this is how the algorithm is working out. Now we can see the working of this algorithm through an example. So here we have a input array which is going to contain 7 values, 7 integers, 38, 27, 43, 3, 9, 82, 10. Now I will be applying the merge sort with a value with this input array, and the lowest index is going to be 1, and the rightmost index is going to be 7. So first the middle value will be calculated, which is going to be 3. So it results in two subarrays. The lower half subarray is going to contain 4 values, and the upper half subarray is going to contain 3 values. Now again, this is again a calling of this merge sort. So again this is going to be called with merge sort this as the input array. So array with lowest index to be 1 and the upper index is going to be here 4. So again this is going to follow the whole algorithm. So again it is going to call the merge sort. It results in breaking off this array into two halves, results in two subarrays having 2 in each of that. So the two subarrays divided would contain 38, 27 and the upper subarray would contain 43, 3. Now again this is going to call the merge sort. So again it will result in two subarrays. The lower subarray is going to contain a single element which is 38 and the upper subarray is going to contain a single element which is going to be 27. Now after having been divided into until a single element, calling of this merge sort is going to be stopped. Now the fourth step will be evaluated. So which is going to be merging of these two subarrays, which is going to result in 27, 38. The first will be 27 and the second value will be 38. Now this calling of the merge sort recursively is going to be repeated for the other part of the arrays also. So it would be until in each of the subarray single element is left out. So which is going to result like this. So again 43 and 3 would have been merged to contain the subarray 3 and 43 in sorted order. Now these two arrays again would be called by merge, which is going to be merged together to have the array as 3, 27, 38, 43 and here it is going to be 9, 10, 82 in sorted order. At last we will be the last merge function would be called so that it is going to result with 3, 9, 10, 27, 38, 43, 82 in sorted order. That is going to be the result of this application of merge sort. And one more thing, whenever the merging is done accepting two subarrays, where the subarrays are treated as sorted order. So how it is going to be done is the first pointer in the first subarray would be pointing to the first element and the same way the pointer which is going to be point to the first element in the second subarray. And those two elements would be compared and whichever is going to be found out lesser value that would be put on to the output array. So here comparing 27 and 3 would be assigned to the output array and the pointer would be incremented to the next element that is 43 and the pointer remains in the same element that is going to be 27. So now the 27 and 43 would be compared and comparing that 27 results in the lesser value, so that would be assigned on to the output array and the pointer would be incremented to the next element which is 38. Now 38 and 43 would be compared and 38 will be assigned on to the output array which is lesser and at last 43 is going to be assigned on to the output array. So that's how the merging of two subarrays is going to be carried out. Now talking about the time complexity, the merge sort results in order of or theta of n log n for all the three cases, worst, average and best, because the merge sort always divides the array into two halves and take linear time to merge two halves. Thank you.